My name is Jason Brudvik, and I'm going to tell you today about our method for viewing data in a web browser, which we have unimaginatively referred to as the HDF5 web viewer at the Max 4 laboratory. Now, before I get to the web viewer, I'll mention just a bit about the Max 4 lab. It is in the small Swedish city of Lund, at the southern end there, about an hour from Copenhagen. Yeah, it's nice. Small city, big university, surrounded by farm fields, so nice place to visit. Here's a nice picture of the lab taken on a summer night. It's a national physics research laboratory that uses synchrotron radiation. It's been officially open since 2016. And you can see in this diagram I've colored the accelerator. We actually have two rings, a big one and a little one. The accelerator and the rings are green as they're in full operation, and then there's about 4 beam lines that are taking users full time. And then there's various other beam lines that are in other stages of development and commissioning, and still some other that I've colored gray that are in some planning phases. So it's still a while until it's all the way up and running. And in the end, we'll have something around 30 beam lines around both rings. And it's hard to say right now since we're just getting going, but yeah, in the end, the data ranges are going to be somewhere between 100 gigabytes to 30 terabytes per week per beam line, so not as big as others, but yeah, pretty big after a while. And all of the data coming out of all the beam lines will be in HDF5 format, or they should be. Right. So first, when the data comes out, people sitting at the beam lines can view the data, like these happy users and staff at one of our beam lines. They have some machines at the beam line where they can do maybe some rough analysis on data that's been stored and dumped into the storage facility at the laboratory. And then the idea is that this storage at the laboratory will not be the thing that holds all the data. A lot of it will be sent off to a larger storage facility at the Lund University, so just a couple of kilometers away. Catchy acronym of LUNARC. And this Lund University Computing Center is part of a larger Swedish-wide computing center called SNIC. So other data may be sent there as well. But then hopefully along the way at each point, whether at the lab or at Lund University, people will have easy access to their data and have the same analysis tools available. And so hopefully it'll be kind of a seamless experience for them. They just know they go to a portal, log in, and then they can analyze their data. Right. Yeah, so then on top of these high performance computing services, we want to have something that's kind of simple, or a couple tools really that are kind of simple and easy to use for people just to kind of get a quick look at their data. And so one of these was to make some simple viewer, and we thought maybe the HDF to do it in a web interface would be handy. For one thing, it's pretty easy access, where you can, if it's on a website, then you can view it on your laptop or tablet or even your phone. And you can view it from anywhere, whether you're at the beam line or at your home institute or riding your bicycle. All right, and then there's no software to download or install, as most devices will have a web browser already installed. So then, yeah, you do away with all this mess of having dependencies and different operating systems and things. Yeah, and of course, you're not going to be downloading a terabyte to your iPhone. So all the files, of course, just sitting in the far north in some basement under the snow. And then, yeah, it makes it nice that there's no maintenance. Right? So the person who's using the software, they don't have to install anything new, upgrade new versions, and if we make some changes, we can just push the changes and automatically everyone benefits from those changes, and we don't have to worry about different operating systems or things like that. Right, so for the backend, originally we used the H5 serve from the HDF group, but then we had a lot of changes and things we wanted to do that were kind of specific to our application and to our facility. So in the end, we decided to go with a more simpler backend. So, but it does some similar things that H5 serve did. So it's a REST API, and I used Flask libraries for this. And then for the file interaction, I actually use a C++ sub-process, and I've been using the H5 CPP wrapper, which I like and I thought was nice. Yeah, and it helps to make it a bit faster. And yeah, and as was mentioned not long ago, I use the HDF5 plugin to decompress some of our images that come out of some of our detectors. And then at our laboratory, we're kind of migrating a lot of our web services to use the central authentication server. So it's like if you're not familiar with it, it's a single sign-on technology. So a user logs into one service and then they don't have to log in again. They don't have to enter their credentials for a certain period of time while they access other web services. So yeah, that makes it nice for the user, and then it also makes it nice for me as an interface, especially in Python. It's quite simple to add it to an application. And then all of our users their permissions and things are handled by Active Directory. So once they're authenticated, and they get all their Active Directory groups and permissions. So then they end up seeing the data that they are only supposed to see. Nothing else. It's the same as if they were to SSH into the cluster or something. Which is nice for me, then I don't have to bother with that. Right, and then the web interface. So it does pretty much everything you would expect or from such an application. I don't need to see myself on camera. Oh, okay, good. All right. All right, so you can browse folders that are on the disk and look inside the files and see what's there. And you can plot the data sets. And I mean, I guess that's pretty much it, right? The authenticating, seeing the right data, being able to browse and display what you see. So, although I'll tell you more about it. Yeah, so I've used the Plotly JavaScript libraries for plotting, which make pretty pictures, and they're pretty fast, and it's pretty simple to display data in a JSON format. And I've used this library called JS3 to kind of visualize the file browsing on the left there. Right, so then yeah, there's a bunch of other kind of small features really, but it's best looked at in a demo perhaps. So here I have a demo version of this application running. So now I've skipped the authentication bit, and it's just using a local system user with some locally stored data. Although the web, the server itself is in Sweden. So if I can click and open all these files, folders and files, and then I can display things like yeah, numbers and text, images, things for a little bit, image stacks. I can step through some image stack or enter whatever number of image I want to look at. Right, and then yeah, then there's a number of kind of things that can happen then on the client side that are provided. A lot of them provided by this Plotly library. So, for example, I can change the color map to something that I like better, but this one's the best, of course. I could change the aspect ratio, so maybe I want to look at it with proper square pixels, or maybe I don't care and I just want to fill the screen. I can look at the display of the intensity distribution, right, or toggle the display of the histograms on the side, and what else? Oh yeah, I have some automatic filtering for hot pixels, which you can turn on or off. I have it on by default, but if you don't trust me or you just want to double check, you can turn it on or off. And all right, what else can you do? Oh yeah, so and then since this is a web viewer, you're not going to want to send a 16 megapixel image to your phone or even your laptop. So it's the image is compressed. I mean, not compressed, but it's decimated on the server side. So, for example, this image here, it's almost 1,000 by 1,000 pixels, but I'm only displaying an image that's 400 by 400. So I've done some averaging on the back end, and then I send it to the web browser. And I haven't done it yet, but one could also, use different amounts of decimation for perhaps a desktop connected to Ethernet versus a phone on 3G or something. But then when you zoom in and select a new region, it's going to go and grab new data and then display it also at the maximum of 400 by 400 pixels. So here, this little region I've selected, it's kind of small. Maybe it's like 100 by 100 on the original image, but here I'm only displaying 40 by 40. So, and if I zoom in, it's gonna, it fills the screen, and it's kind of quick, but it fills the screen at the original resolution that was being displayed, but then it uses the coordinates, sends it to the server, and then grabs a new image, just that bit of the image that it needs. What else? So I have something where I can save an image, or I can, like a PNG output of it, or I can share it with my friends at work. So there's some web address, I can email to somebody, or I can just take the whole data path, which is going to be the same as the data path that you would find on the cluster, or if it's stored elsewhere. All right, so, and you maybe you can't really see it here, but in the URL, there's actually the full data path is given there, along with the region that I'm looking at using a slice type notation. Right, so I guess that's about it for the demo. So there was just a bit more. Right, so for the future, I guess we wouldn't really want to add too much to it. I mean, we don't want to make it into an analysis program. It's really, we just want to have something really quick and easy that you can display data and then see that it's there. But one thing would be not to improve the mobile interface. So right now you can use it on a laptop or a tablet, or even a phone, but it's not. It could be better. I think, especially on a phone, I have not really worked on it at all. And maybe in the future we would want to actually change the background or add to it using HSDS, because we're thinking that maybe this project, along with our Jupyter Hub service, we might want to be able to share notebooks and things, not just within our lab, but maybe elsewhere. So maybe someone at ESRF, someone at Max4, they want to be able to share, look at the same data, share notebooks. So maybe we might want to then go and use S3 storage, and we have some tests planned using this Swedish computing network, SUNET. So we'll kind of test that and see if it's feasible or not. All right, so that's about it. In the end, we tried to make something that was simple and accessible and quick, easy to use. And if you want to play with the demo yourself, you can go to this address. And also on that website, you can find other information and links to this talk, as well as links to the code, which are publicly available on GitLab. And yeah, if you have any questions in the future, you can contact me at this address. Thanks. Yeah.
Any questions? Questions from anyone? Yes.
I'm struggling to be able to visualization online now. Not HDF5 is insurance takes fits. That's everything there. But it's something that there's actually quite a few other implementation calls floating around. It might be worth seeing what everyone else is doing if you're around seeing people combine aspects. I would, like my research use visualization. I know this like strong use of large scale memory data result services, so that might be something where you can different pieces of code and whatever. As opposed to like yeah, this thing. Yeah. That side.
Yeah.
Yeah, I think this is a general question. Could this stuff be embedded in someone else's web application?
Yeah, I suppose so. Yeah, I don't see why not. It's just, yeah, I mean, it's pretty simple JavaScript, and the back end is also pretty simple, and yeah, they don't have to be run on the same machine.
And I was thinking about the test of HSDS, your previous code ran on top of H5ID,
no? No, I didn't actually use H5.
Oh.
I just used directly H5 cert.
Okay. Oh, yeah, the rest of the
So in NSC, I did see like a spreadsheet kind of view of the data. I did think that was very useful.
Oh, for this?
Yeah, you're right. To see the values.
Oh, yeah. I suppose I could. No one has asked for it. So.
In a sense, it'd be very guarded in what we do, because it's you can imagine an infinite list of features.
Yeah, right. Yeah. I don't want it to become too messy.
But this also is part of your. This is not your day job.
Sorry.
This is not your main job. You do this at night or something, right?
Not well.
Because you're a scientist as well.
No, not anymore. No, I'm just programming now.
Okay. Yes.
Jason, about the academic people. What do you think about to improve academic view having some practicability, like instead of see a spreadsheet of a data set, it should be useful to see an image of data set, 3% volume. Sometimes for the volume data, you have a big spreadsheet with a lot of numbers.
Okay.
Well, it should be considered.
Okay. Wait for the next talk. You get an answer to your problem.
No, okay. It's considering capabilities, and it was once again, there are other packages that do it much better. What we were trying to do the idea was that people can do different plugins to HDF. And this is probably if we will enhance HDF, this direction will be gone. So plugin does the job. But HDF really was browsing, but now it has some editing and it created a lot of headache for us and for users because not everything we could edit like Grenoble. Like we want to edit something.
No, it does have limited image.
It has limited image capabilities. I'd like to know more detail about what more you'd like to see.
Strange value that it represents if I use an image, and you say immediately what is the wrong pixel, the wrong value on my dataset. If I make a simulation, I get not a number.
Yeah.
Yeah, we do not dealing with
I thought you could do that. I thought you could probably.
HDF5 is not dealing with not the numbers well, the tools. Like
Well, but you could cover and see whatever value is there.
it's not there.
There's some statistic, you have fines which
Yeah.
an idea.
Actually, I'd like to hear what you would like. So, yes, send us a list because.
Yeah, you know, I think we'll see one too after this, but there are the tools out there that probably provide this.
Yeah.
I just think that we get linked to the site more, made more prominent, that other people can find it.
Yeah, I just made a note actually that what we should have on the HDFU site is links to other viewers. Because as Selena said, we deliberately didn't want to add too much. The same philosophy as yours. We don't want to. But we still want to hear about things that you like because there are, there's certain things like maps and distributed statistics that everybody wants to see. So it's not really things that they're saying, but yeah. So yes, please do. Thank you.
One more. Two more.
Jensen, may I ask you a question? I just see the demos. It's really impressive. And I'm wondering how you differentiate between the pass on the file system and the pass inside the HDF5 file on your demo. When you run the demo?
Yeah.
Yeah, just within the URL.
Oh. Yeah.
You don't have a specific corrector for the pass on the file system and the pass within the because it goes down to the top of Soma, but we've been scratching our head quite a bit in trying to find a uniform way of representing URL, a specific data set within an HDF5 file. And apparently you find a way where I don't guess what you would do.
Oh, yeah. I mean, so I just take everything after the question mark data equals, and then I send it to my server, then I parse it kind of maybe stupidly, but I just look for various possible file extensions and look for slashes, and then
So it's still kind of magic that you see. Thanks for that.
Just wondering, you show 2D data here. Have you also fleshed it out for, say, line plots and slices through high-dimensional arrays as well?
No, I've only looked at data that we've had, so I don't know any other. But if you have some other possible data sets, then I could be happy to look at them.
Would you consider exporting Nexus data as a default not?
Oh yeah, that would be nice. Yeah, but I don't know if any of our beamlines are actually using Nexus. But yeah, I mean, that would be nice to just be able to open a file and see that the default plot is this, and then because I mean, I have some really simple little files I made here, but of course they can get quite complicated with nested folders and things. So it'd be nice to know what's important to look at.
Okay, thanks again.
Any other questions?
That's it.
Okay. Bon, c'est en minute. Et tu prends quelque chose là au début. Tu l'as. Okay. Yeah, okay. So we're carrying on with demos and visualizers.
Okay, do you hear me? Okay, so I'm Thomas Vincent from ESRF. I work in the data analytics unit, and I will talk about Silex, which is a Python project we've been working on for the last 4 years, let's say. And I highlight the features there related to HDF5. So this history Silex initial goals were we are developing applications in my team, and like YMCA or the library Pi5. And there are some codes there that we wanted to put together in a common place and improve the reusability of the code by sharing and put more documented and test things and eventually refactoring things on the way. So that was the initial kind of main goal for Silex, and so that can be available to, within our team and to other people as well. And on the way, because we are still moving to HDF5, to provide some tools to help and support the configuration. So in terms of feature, it's kind of an all-in-one library, so it has a wide scope of things. Some things related to input and output, supporting the, well, what was the current format for acquisition, which is TEC, in support of image like EDF and other formats with the FabView library. And some helpers to convert things to HDF5 and to write Nexus 5. Second aspect is there is some data processing with a focus on performances, and we start off with a few things written in OpenCL, show by OpenCL, to run processing on a GPU. For example, the SIFT algorithm, which is key point feature extraction from images, which allow you to register images together, or filter back projection for tomography reconstruction. And there are a few other things like median filter, the CBF codec for byte offset coding. So things can be done on the chip. You can put more multiple steps of processing, keeping the data on the chip. And the third aspect, it's some Qt widgets that's initially inherited from PyMCA and to get expanded for things for browsing HDF5 files and visualizing data. We'll come back on that. So that's a Python package. Well, API is Python, inside a bit more different languages. License is MIT. We test it on Linux, Windows, and Mac. So latest version before summer was 0.11, and we packaged it for PIP. People from Conda packaged it in Conda. The Debian packager making it available in Debian, which a sample of them. And project is on GitHub, and documentation is available here. So that's it for a brief introduction to Silex. Now I will focus more on what Silex deals with regarding HDF5. So first of all, we have some conversion feature regarding files. So the context is there is some data set in the current format spec, which is ASCII images. And if you want to write something new that you want to keep maintaining, because data will move to HDF5, I think you better to take data as input rather than the other formats. So there are two ways we provide. One is a command line tool, just take the current files, convert it to something that is HDF5 and Nexus compliant with the guidelines we follow at ESRF. And then you can add all your image data within it. That's the first way. And the second way is because it's written in Python, you can do the same from Python. And actually, either from one function call, or you can open your spec file, for example, as a file object, and we provide a H5Py like API on top of it. So you can use it as if it was a HDF5 file. And there you can either save everything and add as a HDF5 file, or you can select what you want to do with it. You have more control on what to do for the conversion. So that's it for the first part, conversion. Then I will give the next part will be about an application that we developed within Silex. Initially, Silex was meant to be a library, but we've added the conversion thing as a script, as a command line, and we added a GUI application, SelectView, which provides HDF5 and other formats, browsing and viewing, other formats by the purpose of the conversion I just explained. So you can open a select file and see that if it was converted. Yeah. And so that's a GUI application based on PyPy and PySide, and visualization is done either with Matplotlib or OpenGL. So for the 3D part, we use OpenGL, shown by OpenGL, and for the 1D and 2D, default is Matplotlib, and there is an option to use OpenGL as well. So of course, it's not only HDF5 viewer, so two other viewers that are Nexus aware in the next slide, and PyMCA, which is also developed here and kind of mother and sister project from Silex. So we took many things from PyMCA, put them in Silex, and PyMCA also leveraged what's in Silex. So it's in the family. So in terms of feature, so yeah, we say 1D, 2D, 3D things. We have support for complex data, and we support any dimension data sets by basically selecting what kind of visualization you want, and then which slice of the data you want to visualize this way. So if you have a 4D data set, you can see that curve images are 3D by selecting what kind of data, how you want to see it, and what you want to see with it. And it provides some tools like drawing masks on the image and scatter plots, cutting profiles, same on images and scatter plots, and some curve fitting on curves. So for the Nexus support, what we provide, well, easy is to advertise the class of each group, the Nexus class, and we try to display what's available as index data. Index data is something in Nexus that allows you to define what should be plotted. And then in each group, in each group you can say what is the default index data, or what is the default things for this level. So you can point towards some plot from the top of your files. So when you open the file, you can show something. So as I said initially, Select was meant to be a library. So what's used in SelectView is available for use in other applications. And yeah, that's just to illustrate that. That's a few screenshots from different applications that's developed here at ESRF, filters around. And so now I will make a small demo of it. So, yeah. So this is HDF5 file. It's data that has been acquired on ID1 and analyzed by PyLeaks library. It's around diffraction imaging data. And so this is HDF5, I just open it, and I get something displayed thanks to the Nexus default things leading to default plot. So this is 3D data. I can go through as a stack of images, and actually it's complex data. So I can choose what I want to display, the phase, the amplitude, or here both using the amplitude as transparency and the phase as the column. And you could get the profile. There you go. And I can either choose here between 2D or the 3D view. So I have an isosurface of the sample data. I can do that with transparent, and I can also display a cutting plane within the data. So that's what is given straight away, because here in the attribute of the HDF5 file, you have the default, which is entry1. And if now I open entry1, I have default, which is data1. And if I come here, it's a index data, and it's giving me which data it should display, and that it is a scalar values. But so I have some hints on how to display the thing. But if I just open a data set here, I have no idea on how to display that. So SelectView proposes what's available. So you could display curves if you want, and slice through the 3D style to know what you want to display. Or you could do the same with images, and then you can change the way you get through the data. And of course, you can see the raw data as an array if you want. And the one. So that's another data set. So this is a low sample. It's for the water buffer. It's from a PM 29. It's been analyzed by a program. And here it's an Nexus file, and you have the same, you have a default plot, but you also have here what's been measured. And it's access to the images. It doesn't change much because it's all the same that it's been analyzed. And then I get the integration. So for each image, the same. And I get all the intermediate results of the analysis within the same. So on top, I get the final result, but then I can get through the file and get the differences. So that's it for me. Thanks for your attention.
Does this answer your question? But is that what you needed, or you need something like a set? Because I thought you wanted the array on top of the image. Any questions? Yeah. No.
So, thank you for a great presentation. Am I right that you developed your own widget?
Yes and no. I mean, for the plotting, for example, we use matplotlib, so I would say I really look at here for the authenticated part, yes. And the other thing, this is Qt, so you have widgets already available.
Do you think there would be some of these which we request in-house refresh before time for a live?
Depends what you display.
I hope that should be there. Should be. If you want to go fast, you would use OpenGL.
Show the 2D demo with the image, with the profiles of inbox and mobile.
Which one?
The example with the 2D developer and
I think some other people use Daisy. Do you use it?
Yes, there are colleagues that are using who are using this.
That's a small image, but
That's around 5 hertz, 10 hertz. Exactly. Okay, any other questions? Thanks again.